Hi, I'm Peter Haddock, and I'm here at the Big Ideas Zone. And you know, folks, that I love a bit of hydrogen, and I think hydrogen is certainly a huge part of our future for the industry, especially if we're going to meet net zero. So I've met Robin. Knows a bit about hydrogen, Robin, don't you? And you've actually got this prototype here on display here, which is the mobile hydrogen Bowser, folks. Something that we need to get the fuel to those final miles to the machine or the static device that's using hydrogen. Robin, tell me all about it. Lots of nice controls in here and lots of hydrogen that can go inside it, isn't it?
Yes, this prototype Bowser has been designed to attract attention from industry. Yep. As you know, we're looking to decarbonize using hydrogen, and hydrogen obviously has its place where electrification isn't always suitable.
Yep.
It's worth noting that we do need an energy mix to be able to reach net zero targets, and hydrogen is clearly able to address some of those areas where electrification just isn't suitable.
Yep.
Obviously, you're not going to put 3.5 tons of batteries onto a tractor. It may well sink into the mud. So this is where hydrogen finds itself in our decarbonisation journey. So the application of hydrogen, it's very important that it needs to be mobilised. Yep. It needs to be able to be transported around a site. It needs to be safe. The emphasis here is on safety. Decarbonisation is part of the journey, but safety is of absolute paramount importance, because construction operators, fleet operators, they want to have that assurance that there's a bit of a stigma about hydrogen, and they have great concerns about its flammability, explosive nature. So it's very important that we operate equipment that has unrivaled safety functionality.
And so we're looking at that here, aren't we, here? So we've got a bank in here, and we'll get a close-up of this for you folks. We've got a bank of control systems here that allow you to actually monitor and regulate what's going on, but also allow you to charge and discharge hydrogen into this unit.
That's
so
exactly correct.
What, this is the prototype, slightly smaller than what's actually going to be released by the team.
That's correct.
But how much are you able to carry from a hydrogen perspective, and explain to the audience how that relates to, say, litres of diesel in that kind of context?
Okay, so it might not sound like a lot, but the system is designed to carry 74.5 kilograms of hydrogen at 500 bar pressure, a 50 MPa service. Now, most commercial vehicles, construction equipment, trucks and like, will actually operate at 35 MPa service, but because there's no onboard compressor, as the compressor is very large for hydrogen, then this 500 bar solution enables us to cascade fuel into the vehicles of a 35 bar service, effectively delivering as much as they need up to the maximum capacity of the 74.5. There could be some residual, dependent on the service duty of the application, there could be some residual hydrogen, but this lends itself to applications like HPU, hydrogen power units, hydrogen power fuel cell generators if you prefer. So our system is versatile enough to have applications throughout various areas of construction and through transport.
So let's go and have a look at the side back of it here, folks. So, what's really important for me about all of this is we talk about the last mile to the refueling. So we can see already there are huge HGVs that have actually been created to take mass amounts of hydrogen into a location. Now we're talking about saying they will refuel a number of these that can be used just like the refueling systems that we've got now for diesel around a job site. And this is why it's all important that we've mounted it on a trailer, isn't it? So the trailer can actually be that next final journey for the hydrogen refueling, because we don't want to, particularly the tracked machines that we've seen launched recently, we don't want to actually be tracking backwards and forwards. We want to take the hydrogen to the machine. That's the best cost of doing so, isn't it?
That's exactly correct. The most efficient method is exactly what you've described there. So the design is that the trailer can actually be, the Bowser can be demounted from the trailer. It can be lifted on these lifting eyes or forklift pockets, and it can be redeployed. We anticipate that some construction sites might operate 2 or 3 of these units, which then means that they can put them into rotation, shift rotation. There are challenges when handling gaseous hydrogen. The recharging and the unloading both leads to increased risks associated to heat. So our system actually operates a self-regulating protocol, which then prevents or minimizes the risk of anything overheating. It may lead to a slightly slower refueling time than what you miit experience at a forecourt.
But that's just generally what we can cope with on site, isn't it?
Exactly, that's it. You're not going to take the Exego elevator to the forecourt. And likewise, even if this was to be used in a transport application, no one's likely to want to drive 20 minutes to a filling station to drive 20 minutes back to gain 30 grams per second when this unit could fill at 10 or 15 grams per second some of those smaller pieces of machinery.
And I think it's really important that we just make sure that we've got to the device with something like this But with the tyres on this, folks, and driving it and hauling it, it's much more expensive to actually track back or take the vehicle out of the job site arena. Bowser's been used for a very long time. Now they're hydrogen, folks. So come on, let's go and have a look at the front end of this. So quite literally, we've got the prototype here. It's going to be a little bigger, isn't it, Robin? Tell me what the size of the final unit's actually going to be.
Okay, so this is indeed just an aesthetic prototype, so we can gain market feedback from the transport sector, the construction sector, and the low carbon vehicle sectors. Effectively, the 74 kilogram 500 bar unit will be a little bit longer. It'll be 1.3 meters longer, and it will be around about an extra 100 mil on either side as well to give it that enhanced capacity. But it'll still be towable and absolutely mobile. The importance of our application is that it's safe, but it's also mobile, and it needs to be designed in such a way that it can be readily deployed and is versatile enough to suit varying applications so that it can be scaled efficiently.
And of course, folks, we see the way in which the industry's worked with battery power. We see people that have actually developed systems where we've got batteries that you can literally replace into the machine. We've got battery power stations and banks and things like that, but what we haven't got until I've discovered this at the Plantworx Big Ideas, folks, with Commercial Fuel Solutions and Robin, is a Bowser. But guess what? We have now. Cheers.
Fantastic, thank you.